Hello there. Well, what is up? I have found a solution to yesterday's problem. So, thing is, I did a little research off stream because it's kind of boring to watch. So, what I did was, let's open it. We need to go to Speed Boost, Coding, Atmel, keyboard, software, and I have a bunch of new files. Now, 1 second. And the first one is the example.hex. This is basically, I think it was a serial to USB. It was something that set up USB, and I have the hex file for it. Found it online somewhere, downloaded it, and yeah, guess we're here now. So I took this file and then I deleted, hex only, deleted everything irrelevant. So we only have the stuff that actually gets written into the RAM. I took this file and then I took the disassembly. Then I put it into a online disassembler and I got this out of this. Now, what does this say? Basically nothing. So I changed up a bunch of things and replaced some hex coordinates of registers to their actual names. So if we search for this, we actually find the stuff we want. Now, you might see that this one is returned. So some function here, it has just ended. So we need something that basically uses the rcall function or break function to get to this point in the program. So we just search for the 00000, then for EC, for goddammit, C, 8, for E8. This way we find this one. So what does it do? It basically loads some values into the registers and then it calls the function. So if we go back to this, I've written down some of the register values here. And what we see is that, first of all, we select the register 0 because we select endpoint 0, so the control endpoint. Then we basically load the control X register into the R24 register, and we basically set the bit of this to 1. So all these 3 lines just enable the endpoint but keep all the other settings. Now the next one loads the R1. I have looked up a bit before the function call. This is the value 0, so it gets set to 0. Then the config 0 register also gets set to 0. And after that, the config register gets set to 2. So it is basically USB driver S. So what we do is we enable it. So this would be the first line. We select select it first. All right, we select it here. We don't select it at all. Oh, because it's already 0. Yeah, we can just also select it to be sure. So then we enable the endpoint 0, which this program does too. Then we load the config1 register with 0x20, 0x22. Something's not right. They just load 0x02. So let's see, what does this mean? It was this one. Oh, there we are. This is not the one. God damn it. This is the one I was looking for. We set the endpoint size to something different than 8 bytes. I don't think that would be an issue. We can test it out, but I don't think that will be an issue, but yeah. So then, what does this program do? It basically loads the value of the same thing we did here. Yes, we load the value of uesta0x to R16, they go to 24, irrelevant, and then we skip this instruction if the bit is set. Now they do it a bit differently. So they basically set the R24 register to 0x, so hexadecimal 01, if the bit is set. If it's not set, it's set to 0. Now, what does this do? Basically does nothing, because afterwards it immediately returns. So we would have to go to this address. So 1, 2, 3, 4, 5. Whoops, 5, 9, C2. And this is not the right one, is it? Wait, no, this is the right one. And so this rcall function is done. It goes down here. And from here it just does some stuff. It basically loads these registers again, but for a different function, and then executes that function and so on. But it does not only set the control register. You see, the R24 immediately gets overridden with 00F0. Wait, no, with the value that is stored in the cell 00F0. But we have other control and other endpoints that get set. So if we again look for, I think 4E8 is enough. We have another one here. Wait. Yes. We have this one. It basically, it sets very different values. So I haven't checked which values that are. I don't really care. Important thing is the 22 register is 8-1. So if we go back to this one and see the 0x, you will see that it will get set to 8-1, which corresponds to basically this bulk type and an endpoint and sets it to in. So it's a bulk endpoint with in direction. So it's a different endpoint. But something very interesting happens after this R24 check gets returned. And that is not this one. We were here. 8.1, right? Afterwards, we do an AND, which automatically sets the set bit in the status register, which basically means equals. If I have to, yeah. So in the end, I can show you actually. So if we search for and make this case sensitive, we will see. This is really annoying. Yes, logical AND. What this does is set if the result is 0, 0, cleared otherwise. So this bit gets set only if it is 0, 0. So basically, if R24 is 0 instead of 1, this bit gets set, which will then basically act like the previous comparison was equal. So we have the break if equal, a branch if equal. So this branch gets executed if the check failed. And this branches to, one second, this key, E84, E84. Next. Okay, here. What does this do? Basically just loads the R24 register with 0, 0 for some reason. This is probably the return value of the function or something, so it means that it failed. So it basically skips everything from here down to here, sets the bit 0 again, and then returns the function. What this does is it skips this. So if it gets executed, the whole function, without the check failing, then basically, this step gets just skipped because rjump2, it just jumps ahead 2 and ends up here. And that way the value will still be 1. But if it fails, it just gets sent here and the value is 0. So what I was trying to say the whole time, all this was about, was just, where are we? Whoops. We're gonna search for UE something again, because I lost my way. There we are. And this is the 4E8. So we search for 4E8. This one, right? So the important thing to notice is that the bit doesn't get checked for the control endpoint. It's irrelevant. They just ignore it. So my big genius plan is to just do the same, ignore that this error kind of gets thrown, and yeah, just check it for all the other endpoints. That way we have basically, I don't know, we just ignore the error. Maybe it works, maybe it doesn't, I don't know. But yeah, that's about what happened off stream. So, undo. This is a check, I believe. Yes. What is this? This is the load of this thing, which we can just ignore. And let's see again. This one should be 0 by default. Can just set it to 0 again. Oh, by the way, I found a funny trick, which is exclusive OR and R0. So basically, if R0 has one bit that isn't the same as in R0, it will be 1, but since it's obviously the same, it will just set itself to 0. So we can just skip the instruction here. Yeah. Now, what was I gonna do? All right, I was gonna just yank this one and paste it on top of after this one, enable. Now this one, right? Probably 0. Oops. And R0. I don't know. Safety step. Maybe, I don't know. Okay. So this should be working. Theoretically. Now, attach device. UD connect. Alt 3. Let's see, what does our USB say about that? Yeah, so we followed this. We just ignore this one. Will not be set if the endpoint size parameter is bigger than the DP RAM size. Yes, okay. Address setup. The USB device address is set up according to USB protocol. The USB device after power up responds to address 0. Makes sense so far. The host sends a setup command, set address address. The firmware records that address in uadd, but keeps address enable, maybe add-in cleared. If the USB device sends an in command of 0 bytes in 0 length package to acknowledge the transaction. Okay, and then the firmware may enable the USB device address by setting address enable, the only accepted address by the controller stored. Okay. After power up reset, it is cleared when USB reset is received or when the macro is disabled. USB E. I'm pretty sure we set this USB con we set this to 8. Probably should unfreeze it. So this would be a A. So what else do we have? Mm. Uh-huh. Whoopsie. This one. No. Endpoint activation. The endpoint is maintained under reset as long as EPN is not set. The following flow must be achieved in order to activate the endpoint. Does it say something here about endpoint reset anytime? Yeah, not really important. Suspend, detach, remote wake up, stall request. Control endpoint management. Yes, this is what I am talking about. Right, did we attach the device? That's kind of an important thing. Simply by setting and clearing the... When the USB device controller is in full speed mode, setting will disconnect the pull-up, then clearing detach will connect the pull-up. So, we theoretically... I mean, what are we doing? Let's just see what we are actually doing. Control F, detach. Not the right one. Hello? There. UDCon. USB device control registers. Writing this bit to 1, it is 1 by default, disables the USB D plus internal pull-up. This makes the USB device controller physically detached from the USB bus. Writing this bit to 0 enables the D plus internal pull-up and physically connects the USB device controller to the USB bus. Cool. Writing this bit to 1 allows the USB controller to generate an upstream resume packet on the USB bus. This bit is immediately cleared by hardware and cannot be read back to 1. Writing this bit to 0 has no effect. Okay, wait. Don't know what that means. Writing this bit to 1 allows the CPU controller to reset the CPU when a USB bus reset condition is detected. When this mode is activated, okay, I don't care what resets currently. Just need to attach it. So we need to set this to 0. UDCon 0. What are we doing? UDCon 0. So, how about we try it out? I need to attach my keyboard. 1 second. Plug in the cable. This is not a complete mess, trust me. Okay. Now we're gonna do the sudo change modifier 777 dev/tty amc0. Gonna put in the super secret password and make send. Now, did it work? Nobody knows. I'm gonna test it out. First, I'm gonna check if we have the waveform, the square waveform, kind of square, I don't know. The output we set, so we know that we entered the loop. It is set. Now I'm gonna test if the USB pull-up is there. It does not look like it. Huh. Not good. What if I attach an actual USB cable to the keyboard? Might help. It is now attached. Does not seem to be doing a lot. I'm gonna plug it in again. 1 second. Sorry. Oh, that doesn't work. Maybe if I reset it. Not really, just some weird power stuff, which is kind of annoying. Thing is, we tested this out, right? Um, oh wait, no, not this one. AVR2. AVR dude. Right, just gonna get makefile Whoops. We're gonna... This is the wrong one. This is the right one. Now. Not with target, but with example. Okay, yes, not this. Takes a bit longer because the file is bigger, of course. Now if I check for pull-ups, 1 second. Well, something is pulled up. Which one is it? 1 second, I'm gonna test again. It's the upper one. Okay. So we're gonna check the schematic or PCB technically. Make it big. Zoom in. So the upper one, D plus. D plus should be pulled up. D minus isn't, which probably is correct. What does it say here? D plus internal pull up. This is kind of annoying. So we know that this works. We just don't know why. Let's see. We can set this one to just 2. See if that helps. 8. Now, do we have a pull-up? Of course we don't. So literally no, like, control endpoint management. Let's see. Shall be cleared by firmware to acknowledge. Yes, but I can't connect it. There is no communication because it's not pulled up. Right. Read and write. Yes, I don't care about that. What I care about is actually using the goddamn device. Huh. So what happens if we just enable another endpoint? Should we just try? I mean, what could go wrong? Let's just do that. Maybe an in endpoint or something. I don't know. Where does it start? Select endpoint. And yes. Yeah. Select endpoint 1. Right. Where are we? This one. This one. UENUM. This one. So for endpoint 1, we need to set this to, surprisingly, 1. Load immediate into R16 0x01. That is not an X, my dude. And this one has to be R16. Let's go. Oh, we have another viewer. Let's go. And then we need to enable it. This would be endpoint 1. And safety step has actually some meaning now. What do we need? We want this one to be or we can't have it be a control type. Selected endpoint table. Wait, no, this is not the right table. Maybe bulk. This sounds like a difficult thing. 1 second, do we have like a description of stuff here? Endpoint 1 and 2. No ping pong mode, but I mean, what is ping pong? Well, let's just go back here. Just gonna select the bulk type, which would be an 8, and we need to set the direction for this. Do we want an in direction or an out direction? Is it relevant for bulk, interrupt, or asynchronous endpoints? Yes, okay. Let's just set out, so 0. So bulk out. And the next would be, so 80, let's just set it. We need to, where is it? This is enabling it. That was the wrong button. Yes, load immediate, again R16. This time 0x80. And we're gonna, oops. What does it do? Select, set bulk bulk out and point. Okay. Now we need to allocate something to this endpoint, which are there other registers we need to set? 1, 2 banks. Well, just stay with 1 bank, I guess. And 8 bytes should work. And then can attach the device. You know what, let's just comment this one out for now and see if we can get the check bit to actually get set this time. Yes. And we make this, and then we send this. If I now see the waveform, it should have worked. Oh my god. Oh my god. There is a waveform. Why is it trigger on the wrong one? Yep, we have a waveform. All right. I like this very much. Let's see, are the pull-ups already enabled? They are not. But that doesn't matter, because we didn't actually attach the device. Now if we... Wait. I'd like to do this after the check. I don't know why. Honestly, just do it now. Make send. Okay. Do we have the waveform again? We do. Do we have the pull-up? We do not. Okay, so the pull-up is the problem now. Why isn't that getting set? You know what? I have an idea. Vim disassembly. And which register was it? UE something. It was the first one, I think, in this list. Yeah, right. UDCon. And E0. So 0x E0. 00 E0. Yeah, this one. And what does this do? We load 24 inside there. We set the 8. Wait, what? which one is D8? 0x D8. USB connect. And we load this one into R24. And then we end with this. So all the bits except bit 4. No. Except bit 0. Basically sets bit 0 to 0. But that does not mean anything. Wait, it does mean something. This is so... Why would anyone do this? Oh my god. So we take this, which... We take the register out, set the bit to... Yeah, set the attached bit to 0. And then load it in. I don't see why this shouldn't work. Well, ours clearly does not work. Although we did set the we did set the detach bit to 0, right? Scroll up there, detach 0, yeah. This one needs to be 0, 0. And we set USB driver UDCON to 0, yeah. This should be 0. I don't see a reason why it shouldn't be. Kind of annoying. Do we have like a workflow for... where do we have attach? But keep the USB attached to the bus. You don't care about this one. Let's see if we go up from here. Aha, USB software operating modes. Configure USB interface. Attach USB device. My brother in God. What in the fuck do you mean by attach USB device? Wait. Oh my god. Is it like set manually? This would be really dumb. The level of D plus can be read and written via the UPOE register. It has to be enabled to write the value. For read operation, the USB controller can be enabled or disabled. Okay. Why would anyone do this? I have no idea. Yes. I think we need to actually... Oh no. USB buffers direct drive enable configuration. These bits select the mode of operation of the USB buffers according to table something. possible configuration of these bits allow to enable or disable USB buffers. I don't need buffers. I need the drive bits. These ones. These bits are relevant only when one of the direct drive modes for USB is enabled. What? These bits are relevant only when one of the direct drive modes for USB is enabled. The values of these bits are output direct drive enabled. Direct drive. So it should be disabled by default. Writing this bit disables it. I don't think we do that. Do we? What was the name? rexcr. Rexy. Yeah, no, that's not a thing. Yeah. USB software enable. What does D do? What do these do? Oh my god, my English. I can read the values. I don't think that's very relevant. If I had to guess. Yeah, no, that's... What do we need to do? USB enable and detach 0. And not suspend. Okay, the sus.pi flag indicates the suspend state has been detected on the USB bus. This flag automatically puts the USB pad in idle, which is bad. The detection of non-idle event sets the wake up I flag and wakes up the pad. Maybe we are currently suspended for some reason. Let's see, where is this flag? Suspend detected after 3. Ooh. Let's see, susp. This flag is set by hardware when the USB controller detects a suspended state on the bus. Idle state from flag can generate a USB general interrupt. If susp bit is set. Writing this bit to 0 acknowledges the interrupt source. We can check that pretty easily, actually. We can just... we just need to... copy that, paste it, comment this out, and load in... Which one? You didn't. This is a funny name. Okay, you didn't. Yeah, I think USB interrupt or something. And now we check if sus pi, pi, sus. Okay, we are. Okay, that was not my plan. We are very sus indeed. So if this bit is set, we want to. Oh, I am so stupid. I don't actually know if we have the waveform. Like if this bit is. It will jump to check anyway. Oh my god, we need to. First of all, we don't even know if it worked. Wait. Same thing here. Wait. Oh no. This is a disaster. Yeah, I'm gonna try it now. Make send. Let's hope we still have a waveform. We do in fact not have a waveform. Well, that's not good. Oh, USB-C. I thought it would work. I thought it was working. What is wrong? We forget to disable suspend mode. We might have forgotten to disable suspend mode. Do we have a flowchart for anything in here? Design guidelines, introduction, and reset after a hardware reset is generated by this stuff. Okay. In case of USB end of reset, I don't care. Power on reset. Cool, I don't care. When the USB controller is in reset state, USB is not set. Yes. USB controller stopped. USB controller is disabled. Doesn't this mean exactly the same thing? USB is in suspend mode. This is important. The device USB controller's internal state is reset. You know what? I'm gonna whereas you didn't. You didn't? Okay. Number E1. Now let's do the example. Wait, no. The disassembly. I'll search for 0x00E1. Does exist. That's not Okay, so LDS. So it loads bit 24 into this, and then it does something and loads it again. Okay. And then it compares it. Oh wait, no. Takes it out. It checks if... What does SBRS mean? SBRS. Skip if bit is set. So if bit number 2 is set, it skips the R jump. Which one is bit number 2? Sophie. Start of frame interrupt flag. This flag is set by hardware when the USB controller detects a start of frame on the USB lines. This software can generate a USB general interrupt. Writing this bit to 0 acknowledges the interrupt source. Writing this bit to 1 has no effect. It basically just checks if there was a frame sent or something. Let's see, what does this one do? Loads it in. It ignores the first bit, which is kind of the one we want. The suspend bit. Isn't it? Yes. And then it loads it back in. Aha. This enables it. This actually sets the suspend to off. Yeah, I think we need to do that too. And like more than once probably. Not gonna lie. This, oh wait, do we? Okay, this part doesn't look like E0. What is E0? Is that like down here? E2, E1, E0, this one. Detach. You wouldn't set this one over and over again, right? So this sets it to 0. What? Okay, disable interrupt or something. Okay, yeah, we need to set this to 0. Enable USB, unfreeze the controller. Probably for this one, right? So this one needs to be let's just say 1. And whoopsie. 0, 1. And what was it called? You didn't or something? You didn't, okay. You didn't, okay. I see how it is. So we basically just check if it's still on suspend. Make send. Do we have pull-ups? No. Do we have a waveform? Also no. God damn it. Gonna check if the pull-up at least is at the start of the program, because after 3 milliseconds it resets. So let's go. This one didn't do it. And does this one do it? Nope. Okay. Wait, error 1? What do you mean error 1? Again? Since when I've been getting errors? What's the problem? Device signature. I have like loose contact or something. Do it again. Still. I'm just gonna plug it in again. Maybe plug out the USB to the computer. And make send. What the fuck? Why is the device signature wrong? I'm gonna check the SPI. Okay, this is very much cringe. Just gonna override. Why did I do this? Dash F. Haha. Make send. Just fucking didn't work. Did I just break the chip? This would probably be really bad if I didn't break the chip. Why is the device signature 1? Hold on, I'm gonna test the SPI again. 1 second. Oh, wait, where is the SPI? Let's see. We have. I think we need this one. Master in, slave out. This would be this one, and I'm gonna check the clock simultaneously to make sure it doesn't do some weird stuff. There is the clock. Now, zoom out a bit. Let's see. Zoom out another bit. One second. Zoom in a bit. Wait, make file. Zoom in another bit. So what is it sending for an address? Wait, once again. 1 second. Okay, there seems to be some... I found the issue, I think. 1 second. I'm gonna make a picture of it. And then I'm gonna connect it to the PC. USB connection. Let's see, is this it? Oh no, this is it. Last one probably. Yes. Where is it? Come on. There. I do not remember how to zoom in this program. Oh, too easy. Never struggled. So yeah, it's always sending this. There are some issues where it can't reach like, what is it, 1.8 volts, and then like 1.7 and 4.8 volts. So there is some issue there of, I guess, whoa, don't rip out everything. Somewhere the lines will be touching, I guess. Where are they here? So here, did I connect these? Maybe I'm gonna... Right, how do I fix... I'm gonna just scrape a bit on the side with like a sharp edge. Maybe it will fix it. I should probably disconnect the power before I do that. gonna use the zoom on my phone. Maybe I can see it better. Where are we? Oh, we have a viewer again. Welcome to the trying to fix something. I don't know what the fuck the problem is. Looks like we have a brownout with the function. So it should be 5 volts always, but sometimes it's just like about 1.7 and then this. But this is consistent, so I don't know if it's like a software problem maybe, or what the actual issue is. Okay, I'm gonna try again. Let me connect up. Right, first. Okay, start this one. Take this out. Put in the probes again. Where do I need to put them? Okay, one up there. And where's the other one? There's the other one. So let's hope it works this time. I doubt it, but everything's possible. So we just gonna make send. Who that? Oh yeah, sudo. I don't know. Super secret password. Well, oh, I need to plug it in. Nice one. Wait, where is the cable? There it is. I need a camera for the stream. So now we just need writes, make, send. It actually fixed it. Wow. I just scraped the contacts with scissors. I hate PCBs. Okay, not my problem anymore, I guess. So next step is see if we have the wave function that right, USB driver. So we have a wave function here, which basically just toggles one port in a loop. And if we get to that and don't get stuck in this waiting loop, we know that the check bit for the endpoints is set, and like this cf config OK, cfg OK bit right here. If that is set, we skip the rjump wait and just head into this one and into the loop. And if it's not set, so if somewhere there's an error, it will just jump up here and do an infinite loop of nothing. So let's hope we have the waveform. Haha, we do not. But important question, does the USB have the pull-up enabled? Because that would also be okay. Never mind, I commented out the attached device. This will not enable the pull-up. So we make again, and we make send again. And let's see. Does not look like a pull-up has been enabled. And the other one maybe. Nope. Would you like this field? Yes, please. What happened? Did I fuck it up again? Device signature 00. Oh no. Oh, this is bad. Power off and power on, I guess. So make send. Okay, it worked. Good. But I guess we don't have a waveform. The hope is still there. It does not look like a waveform is there. Okay. Well. USB driver S. What else could it be? We have this document. Where are we? The device USB controller's internal state is reset. Cool. The DPAC bit, the DP add fields can be set by software. The DRAM is not cleared. Okay. The SPD conf bits can be set by software. After USB-E, the USB controller enters the device state. I mean, I guess with some step has been forgotten. So the pad behavior. Detach 0 USB-E1 and suspend. What was I doing up there? I don't know. So what we are going to do is, and so now if the suspend, wait, this has to be sus.pi, doesn't it? We are very sussy buckers here. The suspend, yes, okay. Susp flag is set by hardware when the suspend state is detected. That was the wrong one. So if this is set, we're gonna go to the waveform. I don't want this. I want this cleared. So if this bit is cleared, which we are, why are we setting this to 1? Writing this bit to 0 acknowledges the interrupt source. Writing this bit to 1 has no effect. Wait, how can I exit the suspend? With wake up, probably. This flag is set by hardware, takes a non-idle signal from the USB line. How do I get out of suspend mode? Wait. Hold up. Oh wait, this is the run. This can generate a general interrupt. If bit is set, writing this bit to 0 acknowledges the interrupt source. Okay, yeah, no. How do I exit the suspend? Like, how do I power up the configure PLL, enable PLL, check PLL log? I do that. Yes. Enable USB interface. Configure USB interface. I'm trying, yes. And attach to the device. How do I wake it up? USB pad wake up, what? It's never lost at activation or deactivation, yes. Sir? Please, that's still possible. I'm pretty sure I'm unfreezing it. Yes. Wait. Wait, am I freezing it? Could be that I'm very stupid. Freeze clock. Writing this bit to 1 disables the internal clock. Bruh. I am very smart. Okay. Do we have a waveform? Please tell me. We do, but I didn't change it back, did I? Where is the suspend thingy? This one is a now. Do we have a waveform? 10 to 1 odds, it's not there. Well, there's no waveform. Do we have a pull-up? We also don't have a pull-up. Okay. But at least we got this out of the way. So it shouldn't be frozen anymore. What else do we have here for registers? There isn't a sleep one by any chance? Guess no. How do I get into active mode? Maybe the pull-up is just at the start. I'm gonna try that one again. Okay, 1 second. Wait. Do we believe this is working now? Okay. Send. Didn't work. Send. Also didn't work. Yeah. This is not the issue, I guess. Wait, we had a waveform. Right. So the suspend bit was cleared, I guess. When USB controller is in reset state. So hardware reset. Hardware reset except from EOR. Was ist EOR? I don't know. End of reset. What? So hardware reset goes into here. Same as this. So we want this to be a device. So we need to set this to 1. And this to 0 to enable the clock. USB controller is disabled and reset after hardware reset generated by something. Reset state. After setting this, the controller enters device state. Yes, okay, but why isn't it working? Can I find anything here that tells me what I need to do, except this one, configure. Yes, I configured it. I enabled it. I checked the PLL log. Did I? I probably did. Yeah, I did. Enable the USB interface. Yes, I did that. Configure it. I think I did that. Register descriptions. Okay. Power on and reset. So we want it to be in idle. What is UID? The macro clock is stopped in order to minimize power consumption. USB device controller's internal state is reset. And detach is set. The endpoint banks are reset. The pull-up is not activated because it's detached. The D plus pull-up will be activated as soon as the detached bit is cleared. Okay. Yes. Yeah, okay. I don't see that, but so if we want to clear this one, right? All we would need to do would be to set this to 0. But it doesn't do that. Oh, wait. Oh, I just had a brain blast. What if features? Where is the memory cut again? Okay, yes. Yeah, okay, yeah. No, this one. Until 5F. 5F. Okay, remember that. Everything above 6.0 is... Where is 6.0? Do we have anything that might be... Okay. I don't know, this is not the best way to look for this, is it? UBCon. USBcon. USBcon. There it is. D8. No, that should work. UENUM. UENUM. Oh, that should work too. UECon. UECon. Yeah. UECon XEB. Okay, that should work too. UECFG. UECFG. Yes, they are all in E. UENUM probably too. Well, I already had that. So now UDCon. Should be somewhere here. UDCon. Okay, I don't see why it shouldn't be attached. Very weird indeed. Yeah. Why is it not working? But I mean, it is working with the example, which is confusing. Oh. Is there something wrong with the PLL? I don't see how that would affect the pull-up. Do I have to set the ports, maybe? Is that an issue? Alternate functions? I don't think the ports actually have alternate functions, do they? They're just USB. Yeah, that can't be it. Power management and sleep modes. Maybe this. Internal voltage reference, port pins, on-chip debug system. Sleep modes. Is there something USB asynchronous interrupts? USB synchronous. In idle we do have them. Other I/O. What's wrong? Why won't you just do what I tell you? Oh, I have another ginormous brain idea. Okay, we are stepping into giga brain ideas. Where is the fucking there? Until FF. Now. At what addresses do I write my stuff? I have a big brain idea. Watch me. That did not fucking work. Now we are talking. If that was the issue, I swear I'm gonna destroy something. What is up? Do we have a waveform? We do not. Does a detachable do something? Not really, no. Not something that is done. I have to say that's pretty annoying. Just gonna vim the example and then split this with keyboard X. Where do we start? Both be starting in the same area. I am obviously done a lot sooner. I mean, it would be pretty stupid if this would be the actual, like, you know what, probably wouldn't surprise me at this point. Yeah, I am kind of out of ideas. Like, what's going on? Doing some weird shit. Bunch of words. Bunch of stuff. I'm just gonna maybe search for everything that's 0, x00, e. What is e1? Here. Oh, not really. Oh my god. Wait. There's a list of all the assembly instructions here. I didn't know that. Kind of funny. Okay, here are the registers. So E1, UD int, interrupt stuff. Don't care about that one. 0. Con has a detach bit. What does it do with the detach bit? Loads in, it compares, it sets it to 0, I guess. Yes. And loads it back in. Then E1. Wait. Sets E0 to that, yes. Then it does the same thing with E1. What is E1? Wait, E0 UD con. And the... Okay, it does clear the suspend flag after detaching. Then it loads E2. Where we are here. E2 address. Does it enable the address? So or, so it sets the first. Okay, I don't get this one. Wait, we are at E2, not this one. Interrupt enable. It sets the first one. It sets the first bit. Okay. Then it loads back E1 and does the same thing with this wake up thing and loads it, goes back to E2, enables it. Okay. I mean, sure. There are more efficient ways to do this, but I guess. Now it loads probably 0. I'm guessing if it's R1. Also can set E2 to 0 and E1 to 0. Yeah, this is all interrupt stuff, I don't care. E1, E2, E1, 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 E2, E2. Can I just... like 2, 1? Is that a thing I can do? Okay, no. E1, E1, E2, E1, E2, E2, E1, E1, E2, E1, E1, E2, 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 E3. What is E3? It's the address. What does it do? It enables the address. Cool. I guess. E1, 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 E1. Okay, we are back at the top, I guess. Yep. Okay. What else could be a relevant register? F. F could also be a relevant register. F2. What does F2 do? UE8 UEB CLX. What is it? UEB UEB CLX. This register is read only. The contents is updated by the USB. For this register contains the number of bytes currently loaded into the current bank. Register contains the number of received bytes into the current bank. Okay. Not that relevant for us. F1. What does F1 do? Probably the same thing, I guess. UE dat X. Whoa. UE dat X. Okay, what's this? The USB data endpoint register is a read-write register used for data transfer between register files. The USB device controller writing to the register pushes the data byte. Okay, this is to interact with the data. For an F0. So what does this do? F0. UEENX. I don't know how to pronounce that one. Endpoint interrupt enable register. Yeah, okay, not important. I just want the configuration to put out an OK. And F4. Well, I can probably just scroll up, right? No. I have to scroll down. F4. Endpoint number interrupt. What does that mean? These flags are updated by the USB controller when a USB endpoint interrupt occurs. Okay. So you can see where I don't care. I'm guessing this is all just interrupt stuff, right? Does F have any interrupt? That's wait, no, data, but equally as useless to me. Does D have any stuff? No. Oh, it has USB con and clock select. Yeah, I'm pretty sure clock select is already correct. Would be nice if I could somehow output the PLL frequency, but I don't think this has anything to do with why this goddamn bit isn't set CFG OK. This flag bit is set by hardware when the selected endpoint size parameter, EP size, and number of banks are correct compared to the max FIFO capacity. This bit is updated when the bit alloc is set, and the USB controller cannot allocate the correct amount of memory. Wait, this bit is updated when the bit alloc is set. Okay, we do that. If the there's a comma. If the USB controller cannot allocate the correct amount of memory for the selected endpoint, the flag bit will be cleared. Do I have to enable the memory somehow? Because I'm giving both endpoints currently 8 bytes. I have 64 bytes for each, and I have there's no reason this shouldn't be able to set. What is this abort? No. Let's see, do we have memory here? Overview. Power on reset, endpoint reset, USB reset, endpoint selection, endpoint activation, address setup, suspend wake up and resume, detach, remote wake up, store request, control endpoint, in, out, asynchronous mode, overflow, interrupts. It's in the USB controller maybe. Probably not. I already looked there. So bus powered device, self-powered device, design guidelines. No. Not really. Memory management. The controller does only support the following memory allocation management. The reservation for an endpoint can only be made in increasing order. Endpoint 0 has to be the last endpoint. No, endpoint 0 to the last. Just read. The reservation of an endpoint is done with its alloc bit. When its alloc bit is set, then the hardware allocates the memory and inserts it between the endpoints. Yes, clearing an endpoint enable does not clear the other configuration core. Mm-hmm. I mean, I don't see a reason why it shouldn't be allocated. Huh. You know what? I still don't see a reason. I guess there are some. I just need to set EP enable, right? That's all I have to set. Kind of annoying, yes. Huh. Configure PLL interface, enable PLL, wait for PLL lock, enable USB interface. I've read this thing like way too often. Yep, I have no idea what's going on. What the fuck is this? Huh. This is annoying. Why doesn't it work? Why? Okay, so wait, why am I getting louder and louder? Power control. This like, why does it do that? It's so annoying. Just chill. Yeah, okay, don't see. Yeah, okay, you know what? I'm just gonna say see you on Monday because oh boy, do I not know what the issue could be. So I guess yeah, gonna send you over to this guy. Looks pretty cool. So later, nerds.